Hello everybody, it's me, James. And a while ago, I set out to make a video about something math related I find interesting. And I want to do it through a particular video game. And I want to do that today. I'll be playing Zoombinis, and I'll be talking, just a little bit, about something called set theory. Now first off, let's make some Zoombinis. Let's see, let's start off with a flat top, single eye, pink nose, springy feet. Hey, it's the first Zoombini. Pardon me. Now, I mentioned set theory. Now, what is a set? Now, I like to think of a set, and the way I tell lots of people to think about it is a set is kind of like a box. It's a collection of items, the same way that a box holds a collection of things from like around your house. Except a box has some special rules. Not a box, a set has some special rules. For one thing, a set can hold as many items in it as you want. It can hold infinitely many. And a set, unlike a box, can hold anything. A set, for example, can contain every number from 1 to 100. And a box can't really do that because numbers are kind of abstract, non-physical concepts. That's kind of a weird example, but that's what I'm sticking with. But a set can also have every counting number from 1, 2, 3, 4, just up and up and up forever. And we call that the set of natural numbers. But that's not super important right now. You can even have sets of like other things that aren't numbers. You can have sets of every relative you have on your dad's side of the family. You can have a set of every Beanie Baby that has ever been made. You could have a set of every Russian ruler or dictator or leader or king or whatever. Or you could just limit it to one type, like strictly Russian czars or strictly Russian prime ministers or strictly Russian dictators. There's not really a limit on what you can put in a set. Well, there are some rules about sets and how you can construct them, but we can go over that later. But for now, the way you could think about it is a set is a collection of items that you can put anything in. But another rule is anything that's in a set is in it exactly one time and one time only. Sets never contain duplicates. We can consider this little group of Zoombinis to be a set. And none of these Zoombinis are identical to any of the others. The game actually expressively forbids you from trying to make an identical Zoombini. For example, let's try and throw this little guy out. Okay. And let's try and recreate our fearless leader, Cernu. Flat top, single eye, pink nose, spring bottom. Won't send him out again. Every Zoombini has to be unique. Just like how every item in a set has to be unique. One way to think about it is like the set of the counting numbers, 1, 2, 3, 4. Each one would only ever appear once. Now, when we think about lists of things, those might have duplicates or have items come up again. But a set can only have a set. An item in a set never duplicates. And that's another way it's different from a box, because like if you have a box full of action figures, you can have two at the same time, but you can't do that with sets. Let's make another little guy. Perfect. I think I've discussed in decent detail what a set is. It's just a collection of items and each item is different. And it can be anything you want. And this group of Zoombinis right here can be considered a set of Zoombinis. Now, let's get going on the next step. Now, the story is the Zoombinis are basically being forced out by a bunch of jerks, and they have to find a new place to live. I love the narrator. And the art. But yeah, a bunch of jerks pushed the Zoombinis out of where they were, and now we have to help them solve puzzles and get to home. And this is the first puzzle. And this will give me an opportunity to talk about subsets and a little bit about logic too. Now, one of these cliffs is allergic to a specific feature of the Zoombini. Maybe it's the type of eye it has, maybe the type of hair it has, maybe the type of nose it has, or the type of feet it has. But one cliff is allergic to one specific feature and will reject any Zoombini that has that type. And the other cliff is allergic to, will accept anything that has that feature. And it will reject anything else. Okay, I'm going to start over from the beginning. Like, let's say this cliff is allergic to flat top hair. Then this cliff will sneeze and blow away any Zoombini with flat top hair. But any other Zoombini will get across just fine. And the other cliff will only accept flat top hair Zoombinis. Let's try just a little bit of experimentation. Okay, this one got across fine. So we know that this cliff isn't allergic to any of the features on this Zoombini. Let's try kind of similar. This one has a flat top and a yellow nose, but sunglasses and propeller feet. Whoa. So we know that this Zoombini was rejected by this face, so he'll be accepted over here. And what's more, because... Okay, for a moment I thought I wasn't going to stop. What's more, because we have a Zoombini with flat top hair on both sides, we know that's not what they're allergic to. And because they have yellow noses, both of them, we know that's not what they're allergic to either. Something else that's like that was tied to set theory when I first learned it was logic. A lot of math is using logic, like the logic you see in deduction puzzles, in order to solve problems and to prove things are true. Or just figure out things. I'm trying to come up with a rule that defines how which Zoombinis are allergic to which cliff face is allergic to which Zoombinis. So I tried essentially the scientific method. I test Zoombinis out to see which ones get across where and try to figure out why. Now, because both cliff faces have a flat top hair and a yellow nose, Zoombini, we know that's not what they're differentiating by. So it has to be eyes or feet. And then it has to be one specific kind. Let's try another propeller foot Zoombini. Okay. That worked. Let's try a third. Okay, it looks like the hypothesis held. I tested out 2 Zoombinis, and I figured out that one cliff would accept one and not the other, and then I tried to guess why that was, and I tested that rule again, and it worked. So let's just move these over. Whoops. I guess it's not the feet after all. Well, what could this cliff be allergic to? It's not the eye. Hmm. While I'm thinking about this, let's talk a little bit about subsets. Now, as you can see, by the end of this puzzle, our little group of Zoombinis will be split into two. One group of Zoombinis will be on this side of the bridge, the top side, and one group of Zoombinis will be by the bottom group. And those will be considered subsets of the original group of Zoombinis we had. Why? Because every Zoombini in one of those littler sets that is associated with a bridge is also a Zoombini inside the total, gang of Zoombinis we started out with. And that's what a subset is. A subset is a set where all of the elements in the subset is also elements of a larger set. Think about it this way: if I had a box full of Spider-Man toys, and then inside that I had a separate smaller box of strictly Venom toys that were associated with Spider-Man, then that box of just the Venom toys would be a subset of all the Spider-Man toys. Because while every toy in the Venom box is a Spider-Man toy, not every box in the Spider-Man box is a Venom toy. I'm gonna start over just from the beginning. Okay. If you have a box full of Legos, that'd be a set. And if you had a box full of just red Legos, that would be a subset of the larger box. Because every element, every item in the smaller box is a Lego, a red Lego. But there are other items in the total Lego box that aren't red. Does that make sense? Leave comments. Oh, I sound like a YouTuber, dear lord. But leave comments or contact me if things don't make sense, and I'll try and explain them as best I can. Now, a funny little quirk of that definition of subset is that any set is a subset of itself. It's if you have a box of books, then a subset would be any box of books where every book in the box is also part of the bigger box. That's a little bit confusing. It's a little bit hard for me to explain personally. It's just It's like a Venn diagram. Venn diagrams are used to explain set theory a lot. A subset, if you treat a set as a circle in a Venn diagram, then a subset of that set would be any circle that's wholly contained in that circle, including the circle itself. And that can be a little bit confusing. That's okay though. Something else that's confusing is the Zoombini rules. What could it be? It's not the eye because we have one eye up here and one eye down here. Maybe I misread it. Maybe it is feet, but this lower bridge only accepts Zoombinis with springy feet. Let's try that instead. Okay. It seems to be working. I think we found the rule. The lower cliff accepts springy feet and is allergic to everything else, while the top cliff accepts everything but is allergic to springy feet. Look, they're celebrating. I got it. Hooray. I'd like to take a moment here just to explain something else. It's like, as you can see, the bridges separated the set we had before into two sets. One's with Zoombinis with springy feet, and Zoombinis without springy feet. And that's kind of what I meant by subsets. Every Zoombini in this set up top is part of the whole group of Zoombinis. So it's a subset. Every Zoombini that has a spring foot is also a Zoombini in the total group. So the Zoombinis with springy feet is a subset of the total group of Zoombinis. And something else that's interesting is this bridge, these two bridges, can be thought of as something we like to call a relation. A relation is kind of like a mathematical rule that assigns items to other items. Think about, you've probably learned about functions in algebra. A function assigns a point in the x direction with a point in the y direction. So, any function or line or equation is a relation because it assigns one thing, an x-coordinate, to another thing, a y-coordinate. These bridges are like a relation too. They assigned every Zoombini that we had originally to two sets, either ones with springy feet or ones without springy feet. And that is something that's important in mathematics too, how relations interact with each other and how they define sets. For example, you can take from the set of counting numbers 1, 2, 3, 4, you can use a relation to divide it into two sets. The set that's only prime numbers, and the set of every number that isn't prime, and so can be written as the product of prime numbers. And that's just one example, but there's tons more. And you can even have special kinds of relations like equivalence relations, or functions are types of relations too. But we can always talk about that later. Let's go on to the next puzzle, because I'm having fun.
These stone guards have their rules, so do proceed with skill. Zoombini's one guard won't allow, the other guard surely will.
How, enchanting.
Another bunch. Oh boy.
Isn't the art for this just great? Okay, I'm just going to ignore that weird noise. But this problem is kind of like, this puzzle is kind of like the puzzle we faced before. You have to get the Zoombinis across into the caves, but these rock guardians have rules on which Zoombinis can pass and which ones can't. So let's try right here. Okay. Oop.
What goes up must roll down.
So this Zoombini was acceptable to this green guard, but wasn't acceptable to this white guard. Well, we know that he will be acceptable over here.
Hello.
Okay, so let's try that again. Okay, so let's try something else.
Enjoy yourself.
These ones all have sneakers. Maybe the rule will be sneaker related. Maybe it won't. Let's try over here. Let's see. Maybe it's eyes related. Maybe the green guard on the right only will accept every Zoombini except ones with this specific eye type. let's try this one.
Go ahead, go ahead.
Welcome.
Or maybe I'm wrong. Well, it's not sneakers. Maybe it's hair. We'll try this one with this hairdo. Oop. Got rejected. Formal logic is the sort of thing that's kind of hard to convey in a game. Especially things about statements about what's true and false. And eventually more complicated statements like contrapositive, and how things being true or false implies other things are true and false. But something I really admire this game for is how it teaches things like, this is basically just applying the scientific method to solving a problem. And that implies things about logic. And I think it's a really clever way to teach kids without really dumbing it down to them or just being overly transparent. That's the problem I have with lots of edutainment games. Having a kid solve 3 times 4 to shoot an asteroid just isn't fun. It's not. But taking some fun animated critters and using logic in the scientific method, although they don't say it as such, to solve problems is the sort of thing that can stick with people. And it's fun. I am a grown, well, kind of. I am a 20-year-old person. I'm adult, and this is fun to me. I'm having a good time doing this. And I hope you are too.
Step right up.
Okay. So let's take a look at what we got. So these green rock goblin things divided the set of Zoombinis into 2 subsets. Ones with this specific hair type, and ones without that specific hair type. And the white rock goblins, only one of them would allow Zoombinis through. I know that because I've already played this level before just to get ready a little bit for this game. But once again, we see how the set can be divided into subsets, and how there's a relation. These rock trolls relate Zoombinis to either the set with this hairdo or the set without this hairdo.
You've done quite well.
This next puzzle is a little bit different.
And so our brave travelers continue on through this dusty wasteland until they meet Arno, the almost omnivorous, one very hungry pizza troll.
Pizza trolls. My worst nightmare.
Fleeing? You're not fleens. Whatever you are, make me a pizza.
I'm going to level with you guys. This one took me a while at first because I didn't fully understand the intricacies of operating the pizza machine. But let's think of it. I want to define my whole approach ahead of time and then work through the problem. Now, this problem doesn't really have as much to do with dividing things into sets and subsets as it does with binary numbers and possibilities. Now, for each topping, there's 2 possibilities for pizzas. You can have a pizza, say, with pineapple or without pineapple, with peppers or without peppers. So that's 2 choices for each one, with or without. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. This pizza machine makes 32 different kinds of pizzas. And we have to make one that the pizza troll would like in order to pass. But if we get too many wrong, he'll bump a Zoombini all the way back to the start of the game. So, how do we make choices? Well, let's start with a cheese pizza. I lied about working through my whole strategy ahead of time. Let's start with a plain cheese. Oh, Arno doesn't like cheese. Now, it may seem like I still have 31 pizzas to try, but actually, I don't. Because I know Arno doesn't like cheese, I can eliminate all of the cheese possibilities from the total pizza list. So while I know this pizza machine can make 32 possible pizzas, there's only 16 left I need to test, because I know any one of them with cheese on it he won't like. This sort of thing is often represented by a sort of tree diagram. So, let's try one with just mushrooms.
Something on that I don't like.
Okay, Arno doesn't like mushrooms. So we know not to give him a pizza with cheese or mushrooms. Now, there's only 8 possibilities. With or without pineapple, with or without peppers, and with or without pepperoni. Let's try pepperoni.
Something on that I don't like.
Okie dokie. Now there's only 4 possibilities left. Let's try just peppers.
More toppings.
Okay, so he does like peppers. But we need to add more toppings. Well, we know he doesn't like cheese, and he doesn't like pepperoni, and he doesn't like mushrooms. So the only topping we can add is pineapple. And this pizza should pass us through.
Oh, my pizza.
Hooray. Well, we've satisfied the pizza troll, and now we can get going.
Splendid job!
Just everything about this game is so nice. The art, the music, the puzzles, I just love it.
Hold on! What's this? A campsite with hot soup all ready to eat? Looks like a fine place for Zoombinis to relax. But when they're ready to move on, they'll need a group of 16 along the path.
This little spot right here is a place where you can store Zoombinis. So that way, instead of starting over from the boat every time, you can store some Zoombinis here and get them through the next part of the trial, through the next group of puzzles. I'm going to stop the video here for tonight, but I think we've covered some good ground. I went over some basic stuff with sets and subsets. I went over relations a little bit. I've went over how this game goes over like the scientific method of coming up with a hypothesis or a rule for something, testing it, and then modifying it if it doesn't work out. And maybe, in the future, we'd be able to work through some actual formal logic with like if-then statements. If you have any questions or any comments or concerns about this video, please do voice them. I want to be a math professor and a math educator in the future, and I think this is good practice, and I think it's a good way to show people things with math that they don't normally see. Lots of people only think of numbers when they think about math, but they don't realize it can also be things like solving puzzles, even ones with no numbers in them whatsoever. And I think that's a shame, because I think more people would be interested in math if they knew that. So if you want to know more, or if there's something I could have explained better, then please don't hesitate to tell me. And have a lovely, lovely day. Goodbye now.